Hey everyone, we're going to look real quick at number 10 in section 5.4. The instructions are to evaluate using the fundamental theorem of calculus part 1. That's the way I abbreviate that. And this is the definite integral we're going to evaluate. So no more long sums finding r sub n and taking the limit as n goes to infinity, right? We're going to use the results of the fundamental theorem of calculus, which says find the antiderivative of the integrand, the function we're integrating, and then simply evaluate it at the upper limit and at the lower limit, and then subtract in that order. So what's the antiderivative? Well, I've got 8 as a constant multiple. The antiderivative of t cubed by the power rule is 1/4 t to the fourth. Right? We add 1 to the exponent and divide by that quantity. And then so here I'll pull out the 4. Antiderivative of t squared is 1/3 t cubed. Just clean this up a little bit. Of course, this is the way you should write it. And after you find the antiderivative, you want your evaluation bar, upper limit and lower limit there. So notice the difference after we integrate. Before we have the integral sign with the limits of integration. Now we have the evaluation bar after the expression. So just simplifying, 8 times a fourth is 2, and 4 times 1/3 is 4/3. So I plug in 0 first into this antiderivative. Of course, this will be 0 and this will be 0, and so the net is 0. Subtract, right, the evaluation at -2. So this, if we call this antiderivative here capital F, right, this again is f of 0 minus, and this in the parentheses is f of -2, our lower limit. So I plug in -2. Be careful, if I raise -2 to the fourth, I get a positive 16, right? -2 times itself 4 times is positive 16 times the 2 is 32. Here I cube -2, so cubing -2 gives me -8, right? -2 times itself 3 times is -8 times a -4/3. Well, negative times negative is positive. 8 times 4 gives me 32/3. So cleaning this up, 32 plus 32/3 is 128/3, and 0 minus 128/3 is -128/3. So there's the answer, and I hope this is helpful and makes sense.